Ever wonder what exactly keeps the lights on and all your gadgets charging without, blowing a fuse? Well, it's not just luck. It's actually this brilliant, kind of invisible rule that's constantly guarding your home's electrical system. And today, we're going to pull back the curtain and demystify it.
So let's kick things off with a moment that I am pretty sure has happened to every single one of us. You know the drill, right? You're making some toast, the microwave's going, the coffee maker's brewing, and then all of a sudden, click. Everything just goes completely dark and silent. So frustrating, right? But here's the thing. That little click isn't your house failing you. It's actually a critical safety feature doing its job perfectly. It's your home's electrical system literally protecting itself, telling you, hey, you've asked for way more power than I was designed to handle. See, every home has a very carefully calculated maximum capacity.
Okay, so who gets to decide what that capacity is? And how in the world do they even figure that out? Well, that brings us to the official rulebook that keeps all of our homes safe. This is it, the National Electrical Code, or the NEC for short. You can think of it as the master blueprint for pretty much every electrician out there. It's got all the rules, all the standards to prevent electrical hazards, and it's exactly where we find the answer to our overload problem. All right, take a look at this. This is the actual language straight from the code. And if that looks like some super dense technical jargon to you, that's because, well, it is. But buried inside this one sentence is a really, really smart principle for keeping us all safe. So let's translate this into something we can actually understand. To unpack that dense rule, we're going to use a simple analogy that I think makes it all really clear. Your home's power highway. Just imagine for a second that all the electricity flowing to your appliances is like traffic moving on a big system of roads. Once you see it that way, everything else just kind of falls into place. So here's how it all maps out. The main service, that's the giant interstate highway bringing power to your home's main panel. From there, you've got feeders, which are like the major avenues leading to different neighborhoods, say your kitchen. Then you have the branch circuits. Those are the final little streets that go to each outlet and light switch. And the cars on the road? Yep, that's your electrical load. Every single appliance, from your refrigerator right down to your phone charger, is a car on this highway. So a load calculation is basically the job of an electrical traffic engineer. Their entire job is to look at all the potential cars, all your appliances, and then design a highway system that won't get completely gridlocked when you turn things on. That click from the circuit breaker, that's an electrical traffic jam. Now, here's where it gets really clever. See, the code avoids making a huge mistake. It would be so easy to just build a massive, oversized highway for some worst-case scenario that's probably never going to happen. But the NEC is much, much smarter than that. The code is realistic. It knows you're probably not going to be running your air conditioner, your oven, your hairdryer, and every single light in your house all at the exact same second. That would be like assuming every single car in the entire city will be on the main highway at precisely 5 p.m. It just doesn't happen. And this brings us right back to that key phrase from the code, demand factors. This is the secret ingredient. It's the tool that our electrical traffic engineer uses to plan for realistic traffic, not some imaginary traffic apocalypse. So a naive calculation would just add up the maximum power draw of every single thing in your house. The result, a system that is hugely overbuilt and incredibly expensive. But the smart calculation, the one that uses demand factors, it estimates the likely maximum load, which creates a system that's both perfectly safe and cost-effective. Now, while the real math gets complicated, you can think of it like this. Instead of planning for 100% of the possible load, the code might let an engineer plan for, say, 80% of certain loads because it's understood they won't all be running at once. For instance, it might say to count the first few kitchen appliances at full power, but any extra ones only need to be counted at 40%, because honestly, what are the odds you'll be running the blender, the mixer, and the waffle iron all at the same time? This makes sure our power highway is big enough for rush hour, but it's not a giant empty parking lot the rest of the day. So the crucial point here is that this isn't just some abstract rule for electricians. This one calculation has a direct and daily impact on you and your family. I mean, the benefits are huge. This one calculation is what prevents wires from overheating and causing fires. It protects all your expensive electronics from getting fried by power fluctuations. It ensures you have the reliable, safe power you depend on every single day. And it does all of this without making your home's electrical system unnecessarily expensive.
What it is really is an invisible system of safety and intelligence. It's not designed for some theoretical world where everything is on all at once, but for the messy, unpredictable, real world that we all actually live in. It's practical, it's smart, and it is always working in the background to protect you.
So the next time you plug something in, remember that whole complex power highway designed to handle it. It really makes you wonder, what other invisible, brilliantly engineered systems are quietly working all around us, keeping our world running smoothly?